Question number 3, back onto hyperbolic functions. We're trying to differentiate this, trying to find dy by dx. Now there's no way we can directly differentiate arctan, same as there's no way we can differentiate arctan. So we use the same method as we would for arctan. So we're going to do the tanh of both sides. So tanh of y is x over root 1 plus x squared. Differential of tanh is sec squared, which is on the formula sheet. Double check, I'm pretty sure it is. Yep, differential of tanh is on the formula sheet, so sec squared. Sec squared dy y, and because we're differentiating with respect to x, I'm going to have to put a dy by dx. Because what I've done is I've differentiated with respect to y, then I put a dy by dx, and the dy's will cancel, so it's differentiated with respect to x. So I've done this effectively. I've differentiated tanh y with respect to y, then put a dy by dx here, which means I've ended up differentiating tanh y with respect to x. Okay, that's implicit differentiation. So that's a square there. Differentiate the right hand side. I'm going to have to, let's just write this for a minute. I'm going to have to use quotient rule or the product rule, whichever. So I'll leave the left hand side for a moment. So this side is a differential of x times 1 plus x squared to the minus half. Okay, could use the quotient rule. I'm going to use a product rule, not sure. Generally I would suggest, because it's a quotient, you'd use a quotient rule. I may be making all work for myself here, but anyway. So uv, and I'll carry on, so differential of that times that, so it's 1 plus x squared to the minus a half, plus that times the difference of that. So the minus a half comes to the front, and the 2x comes to the front. So I get minus x squared, and then I reduce the power by 1. Okay, and the general technique then would be to take the lowest power out. Got a common bracket. This power minus half, that's power minus 3 over 2. So I'm going to take the minus 3 out of 2 out, which will then make the other power positive. Okay, 1, take away 3 over 2 gives me the minus a half. Still on the page, yep. So it gives me 1 plus x squared minus 3 over 2 times, well, just that. Now left hand side, sec squared y is 1 minus tanh squared. So sec squared is 1 minus tanh squared. So I put down here 1 minus tanh squared y, and I've got the dy by dx. Okay, now again you remember, this is how I remember it, but you may have obviously better memories than me. I know that 1 plus tanh squared equals sec squared. So I had little notes aside here. Green. 1, if you can't remember these identities, 1 plus tanh squared equals sec squared. And because tan squared involves sine squared over cos squared, so it involves a sine squared, then you change the sign. It's Osborne's rule, I think it's called, if you want to look it up. Osborne's rule. So most of the trig identities, convert to hyperbolic identities, with the proviso, if you're involving a sine squared in your trig identity, it then becomes a negative. Okay, so that, anyway, that's a little bit of an aside. So tanh squared, we know what tanh squared y is, because at the top we've got tanh y, so tanh squared, so we've got dy by dx times 1 minus x squared over 1 plus x squared equals what we had from the right hand side. Simplify the left hand side. Run out of paper. There we go. Simplify the this here. So write this as 1 plus x squared over 1 plus x squared. So 1 plus x squared, take away the x squared, is 1 over 1 plus x squared. Almost there. Okay, and then I'm going to multiply this side by 1, so dy by dx, multiply by 1 plus x squared, which changes this power to a 1 plus x squared to the minus a half, which equals, we write it back in the form they want it, and then let's write proved at the end, or QED or something similar. Okay, so that was proved. As I said, the algebra may have been slightly simpler, I don't know, if I'd have differentiated this using the quotient rule. Okay, but I'd have ended up the same result. I suspect the algebra might have been a little bit easier.